Hi, good morning, everyone. This is VMware and AVi Networks, now part of VMware, presenting a webinar on the topic of VMware Horizon and load balancing for VMware Horizon. AVi Networks, as you all know, was acquired about 6 months ago by VMware, and we have now launched a new integration with VMware Horizon that allows you to deploy flexible load balancing with VMware Horizon VDI deployments. And I have today two speakers who are going to take you through the details of the integration and a demo of how that integration works. I have Ashish Shah, who is Senior Director of Product Management at VMware. And I also have Raghu Rajendran, who is the Technical Product Manager in the AVi Networks team as well. So welcome to the webinar, and Ashish, why don't you kick it off and get started?
Thanks, Chandra, and thank you for joining us today. And there's the agenda for this webinar. We'll give you a brief introduction to the NSX Advanced Load Balancer, or the AVi Networks Load Balancer. We'll talk about the pain points of the traditional load balancing solution, the appliance-based solution for VDI, and then we'll introduce how AVi solves the problem for VMware Horizon. After that, we'll do a technical deep dive and do a live interactive demo, followed by a case study, and then open up for Q&A. During the session, if you have any questions, please post your questions on the Q&A panel, and we'll answer as we go.
Thank you, Ashish. And one more point of logistics, everyone. We will be sharing a recording of the webinar as well as the slides from today's webinar shortly after the webinar is concluded.
Okay. So AVi Networks, as Chandra said, was acquired by VMware about 6-7 months ago, and it's a full stack enterprise-grade layer 4 to layer 7 application delivery solution. It provides solutions around any cloud environment, on-prem, public cloud, containers, whether you're running a VMware stack or you're running a non-VMware stack. It's a fully featured solution from local load balancing, global load balancing, web application firewall, and full application security, built-in DNS and IPAM, container ingress and egress services, and real-time application monitoring and analytics. So it's a full-featured solution that's truly multi-cloud across all of your environment. And in this case, we're going to focus on how this AVi solution offers full-featured load balancing for Horizon. Now, before the acquisitions, AVi's been around for 6+ years, and we have Fortune 500 to Global 2000 companies who have moved from the legacy hardware and even software appliance-based solutions to a software-defined solution with AVi. And these customers include some of the largest financial services companies, service providers, retailers, technology companies, travel companies, and so on in both North America, Europe, and Asia. So now let's switch to the pain points, the topic at hand around VDI, and the pain points with the traditional load balancing solution. Today, when you're deploying a VDI solution and you deploy the legacy hardware appliances or even software appliances, the operational pain of installation and provisioning itself is very high. Why? Because you have to worry about manual capacity planning. You have to procure those appliances, connect them, provision them, make sure they are in the right security zone, and so on. So it takes days and weeks to provision. The second issue, once you even provision that, is you deploy them as active standby pair, which means by definition you're wasting at least 50% of capacity, which is a criminal waste of capacity when you're deploying in this day and age of cloud. You're deploying them as active standby. And not only that, because these are legacy appliances with monolithic architecture and fixed siloed capacity, you have to over-provision them for future capacity growth. It doesn't give you an elastic scale-out architecture. So you end up not only wasting capacity for standby, you also waste capacity for over-provisioning. Beyond that, because these are black boxes, they don't give you the visibility, the analytics that you expect from a modern solution. They're very hard to troubleshoot. And that results in user experience issues, which is the last thing you want in a VDI solution. And on the management side, you have to worry about managing each appliance pair one at a time, manually upgrading them, manually troubleshooting them. There is no centralized pane of control or management. And when you're looking at deploying your VDI solutions on-prem versus in public cloud environment, you have to sometimes look at different solutions because not every solution is suited for every environment. What you need instead is something that is a consistent, software-defined, modern architecture. And that's where the AVi Vantage Platform, the NSX Advanced Load Balancer comes in. AVi is the only solution that has a centralized control plane and a distributed data plane. The control plane is the brain of the system. This is a single operational entity. It's a single REST API endpoint. This is where you configure and provision your web. The controller automatically spins up and scales out your service engines or the load balancers. So the service engines themselves, again, a piece of software, they can run anywhere. They can run on a bare metal server, they can run as a VM, they can run as a container, on-prem, or in public cloud. Operationally, you have a single centralized fabric. Performance-wise, you have a distributed scale-out architecture. So you manage a controller. The controller manages lifecycle of the distributed data plane, spinning them up, spinning them down, making an active-active fabric that is auto-healing and auto-scaling. In addition to it being multi-cloud, it also provides tremendous amount of telemetry data. We'll show you that in the live demo. And finally, it's a fully automated solution. And when we talk about automation, we talk about two types of automation. One is API-driven programmability. Every object in AVi is accessible by API. And we have Python and Go SDKs. We have Ansible and Terraform out of the box. But that's just one part of that. The real automation is decision automation, where you configure a whip. The controller decides then, should I add initial capacity? Should I scale out? Or can I use my existing capacity? And once it decides that, it actually does the task automation of spinning up those additional VMs or containers, plugging them in the right network, and start running traffic on them. So an elastic public cloud-like experience with a full-feature enterprise-grade solution, regardless where you're running. Okay, so that brief introduction to the architecture, let's switch to how AVi solution provides enterprise-grade load balancing and security for your Horizon environment. So this is the high-level architecture where the AVi solution provides load balancing, layer 4 and layer 7 load balancing for VMware Horizon solution, sitting in front of both connection servers and UAGs within a pod, and then providing multi-cloud, multi-site, global server load balancing with the same solution, with the same controller, across multiple regions and multiple data centers. With that, let me pass the ball to Raghu, who's going to go through a technical deep dive on how the solution works, followed by a demo. Raghu, over to you.
Thanks, Ashish. Going into detail into some of the deployment options that we have to load balance Horizon protocols. In front of UAG, we have 3 deployment options depending on the use case. And in front of connection servers, it's basically going to be an L7 virtual server or a virtual service in AVi language to load balance the Horizon XML API protocol. We will look into the deployment options we have for load balancing in front of UAG in the next few slides. The first option that we have is a single whip with 2 virtual services. In this deployment, we will have an L7 virtual service for the primary XML API Horizon protocol. This protocol will be load balanced to one of X number of UAGs, which will be the members of the load balancing pool. And then the connection is forwarded to the connection server for user authentication. Once the user is authenticated, the secondary protocols will be serviced by the L4 virtual service and will be sent to the same UAG using source IP persistence so that the connection does not break. and then the UAG forwards it to the assigned remote desktop. Some of the key points to note in this deployment method is the SSL termination for the HTTPS XML API protocol will occur on the L7 virtual service on AVi, and AVi will re-encrypt it back towards the UAG. One of the key advantages of using this deployment option is the analytics that we provide for the XML API protocol. The second deployment option is using a single L4 virtual service to service both the primary XML API protocol, and once the user is authenticated, the secondary protocols as well. Again, we will have source IP persistence in this deployment method, and then the UAG will forward the traffic to the remote desktop. Why will you choose this option over the first option? There are a couple of use cases where you would want to deploy the L4 virtual service. The two main requirements being the smart card authentication for Horizon, where UAG has to terminate SSL connections. And if you have a deployment requiring NIST or HIPAA compliance, then you would go for this deployment option, where the SSL termination has to be on UAG and it has to flow through the load balancer. The last deployment option is for a use case where source IP affinity is not possible. One example being the Horizon solution is deployed in a spoke site and all the connections come from a single NATed IP. So the source IP affinity will not achieve proper load balancing. In such cases, we suggest to go with this deployment where the primary XML API protocol will be load balanced to one of the UAGs. Once the user is authenticated, the secondary protocol is directly redirected to the UAG that serves the primary protocol, and then the connection goes to the remote desktop. Why is it called N+1 VIP? In this case, you have to assign a public IP to the load balancer with virtual service, which is servicing the primary protocol, and public IPs to each of the UAGs in the network. That is why it is called N for N number of UAGs plus 1 for the load balancer VIP. The disadvantage, of course, is that you need multiple public IPs for this solution. But the advantage is if source IP is not preferable, you will have to choose this deployment option. For connection server load balancing, only the primary protocol, the XML API protocol, is load balanced by the load balancer. The secondary protocol goes directly to the remote desktop host, either from UAG or for internal clients, directly from the internal clients to the assigned remote desktop. Same VIP can be used for both internal and external clients. And while deploying the solution, you could combine these two service engine into one. So you could have the same service engine having both virtual services, one for connection server load balancing and one for UAG load balancing. This is the architecture, how it will look if we are using GSLB with multi-site. So per site, we will have load balancer load balancing the connections to UAG and to the connection servers, plus a GSLB service engine, which will return the IP of each site, either based on geo algorithm or any other algorithm of your choice, based on source IP or geo. Anything can be configured as the GSLB algorithm. So that is how we will configure GSLB to load balance between sites in a Horizon deployment. I will quickly run through the demo now. So I will be switching windows. This is the AVi controller. And I will be demoing the L7 plus L4 shared virtual service deployment option. So as you can see, I have an L7 virtual service and an L4 virtual service, both sharing the same IP. Before we go into the demo, I will quickly run through the configs that we have for Horizon. We are sharing the virtual IP with the L4 virtual service, and we are listening on port 443. From the official supported code, which is 18.2.7, we have a dedicated profile for VDI, which is the application profile use. And the TCP profile is also the system defined TCP profile. Just showing the pool settings. We have the load balancing algorithm as consistent hash with source IP. This is the load balancing algorithm that is going to be used to achieve the source IP persistence. All the requirements to deploy this mode and the other two modes have been documented in our deployment guide for Horizon. Quickly looking at the L4 virtual service config, you can see it is sharing the IP with the L7 virtual service, and I have all the secondary protocol ports added as the front end. So we will be listening to all these ports for Horizon. 8443 TCP and UDP for BLAST, 4172 TCP and UDP for PC over IP. We will also be listening to 443 UDP because the primary protocol can sometimes use UDP 443. We are using system defined profiles for the application profile for both the application profile and the TCP profile. For UDP, we have a VDI specific profile where some of the required timers have been modified, which is required for VDI. Just showing the pool settings. Again, the load balancing algorithm matches with the L7 pool to achieve source IP affinity, that is consistent hash with source IP address. We have health monitor, which is attached for the UAGs. This is the same health monitor which will be attached in the L7 virtual service as well. And we will be monitoring this URI, favicon.ico. This URI monitors all the UAG services in a single health monitor. For example, if one of the UAG services, like in one of the edge service settings goes down, then the health monitor will go down. So we will be using this URI to monitor all UAG services. Looking for a specific response code, we'll look for a 200 response to mark the health monitor as up. That is it for the configuration. I will quickly initiate a VDI session and we can take a look at the logs. So this is my Horizon client and I will connect to my VIP. So this is the domain name or the DNS name for my VIP. I have users configured in my Horizon backend, authenticating to one of the users to open the session. I will use VMware Blast for this particular session. And the desktop is loaded. Going back to the AVi virtual service, this is the L7 virtual service. We have each transaction that was generated by the primary protocol that is logged. I have enabled certain logging which will show us non-significant logs. And these are all the transactions that took place for the XML API session. Drilling deep down into one of the transactions to show what data we can get, right? Straight up, we can get the round trip times at each hop between the client and the load balancer and the server to app as well. How this helps is primarily in troubleshooting. If a user complains of a slow session or a drop in session, we can take a look at the round trip times and see where the delay has occurred. Additional details, we get the client IP, the location the clients are coming from. This IP was identified to be internally originated, so it's marked internal. The device that is originating the connections, the TLS versions. So if you want to identify how many users are using a lower TLS version, we can find that. The load balancing parameters, which server was chosen to send the connections, and what the source port was, etc. We do have an option additional logging to see all the headers in the transaction, and if you wanted that, we could enable that option and use that for troubleshooting. For example, what cookies were sent by the server, etc. And this is the power of the AVi analytics that Ashish was mentioning yesterday. Each and every transaction at an L7 layer is displayed, and all these details are displayed when you just enable logging. And we have significant logs as well, where AVi displays what logs it considers as significant and why it was considered as significant. Say, for example, a connection was dropped, we would display it as a significant log with all these details in them. Another useful way to look at the analytics is an aggregated analytics. So if you want to see what TLS versions they were looking at, etc., or what servers the user connections were going to, then we can look at the summary tabs on the right hand side to get that particular information. Each locations, what locations the users came from, etc. This concludes the demo. Ashish, back over to you.
Thanks, Raghu. Thanks for the live interactive demo. So to as you saw in the demo and the slides, right? It's a very simple solution. It's very easy to deploy. It's very easy to troubleshoot. Gives you real-time analytics, and the same solution that you saw in the demo today, you can use on-prem, in public cloud, and basically in a hybrid cloud environment as well. And with a controller-based automation of automatic service engine spin-up and scale-out and capacity management, as well as the self-service capabilities for troubleshooting and the real-time application analytics, it's significant operational cost savings you get from that. You also saw how easy it was to get end-to-end visibility from latency to details about the end users, whether they're coming from, and if there are any issues, whether it's a network issue or an application issue. Extremely easy to troubleshoot. And all of these translate to operational cost savings, but also as a product itself with the software-defined architecture, with the active capacity deployment and full automation, there's significant upfront cost savings on the CapEx side as well. In fact, our customers end up saving anywhere from 30, 40, sometimes even 50% total cost of ownership savings compared to the legacy appliance solutions. And we, in fact, do those kind of savings comparison for real-world scenarios. Moving to the next slide, let's talk about now a real-world case study where VMware IT deployed Horizon VDI with AVi as a load balancer in record time. If you're aware, recently VMware acquired a Carbon Black solution, Carbon Black as a company, and VMware IT wanted to quickly bring the newly acquired teams, employees, to the VMware set of applications through the Horizon VDI solution. And the VMware IT team was able to deploy these in a record time with its always multi-cloud capabilities running Horizon on VMC on AWS, with the elasticity in Active Active configuration eliminating the over-provisioning for worst-case scenarios, and the simplified deployment and operations providing real-time visibility into the health of both the UAGs and connection servers as well as end-user insights. And the VMware IT team was able to save significant amount of both operational cost with simplified deployment and troubleshooting, as well as upfront product acquisition costs, given that this is a software-only solution with its active-active deployment model. We'll be publishing this case study in the next few weeks, where you'll be able to get real quantifiable benefits of a real-world deployment scenario of AVi with VMware VDI. Let's go to the next slide. So where do you get started? Well, the first link is to the product documentation and associated collateral on AVi or NSX Advanced Load Balancer on VMware website. The second link is a full product documentation of using AVi for VMware Horizon VDI. What you saw today, this link includes detailed reference architectures, sizing guides, use cases around multi-data center with GSLB, active DR scenarios, and so on. It has a full suite of documentation and use cases for deploying AVi for Horizon. In addition, you can also get an on-demand demo request through our scheduler demo link. We have hands-on labs around AVi product, including GSLB and VAF, on the VMware hands-on lab site. And if you're interested in saving money with your VDI deployment, do reach out to us. We do, as I said earlier, we do custom business value assessment where we will give you real concrete cost-saving numbers by moving from legacy hardware or software appliance-based solutions to a modern software-defined solution with AVi. Okay. At this point, let us open up for questions. If there are any questions, please ask them on the Q&A panel.
Thank you, Ashish. We have a couple of questions that have come already. One of them is from a customer who is in the telco business. And the question is that we have a need for VDI with the ability to support voice. And this is something that we have found particularly hard with traditional VDI solutions. And we're wondering if this helps with that.
Sure. Raghu, you want to take that?
Yep. So we have tested VDI with video and voice with this solution. Now, depending on the challenges that you faced with the traditional load balancer, based on that, we will be able to give you a specific answer. So if you could reach out to us and let us know in specifics what the issues were, then we can answer that in a better way. But from our testing standpoint, we have tested with video and multiple different apps that customers generally use with VDI, and the solution has been certified with all those apps.
Perfect. Okay, so Brian has a question about packaging, or sorry, Tim has a question about packaging and whether this is included with a specific version of Horizon or if it is currently a bolt-on.
Right, I'll address that. So at this point, it is it's an added-on software that you download and install. we are working on bundling this. We're looking at various bundling options, which will be available over the next few months.
Great. So another question from Brian is the kind of network insights that are available that you just shared is very interesting. We use VeloCloud for SD-WAN, and we're looking to prove the ROI with this solution. Do you have any content on that in that area?
So for VeloCloud, I'll encourage you to reach out to the VeloCloud team. We do have content specifically talking about AVi load balancing solution. We do have tools that can show you the ROI and then the TCO savings.
Yeah, he was specifically asking about AVi. Thank you. So the other point that I would want to make to all the webinar attendees today, folks, there's a lot of content as well in prior webinars that we have done on a variety of different load balancing topics, including AVi's analytics capabilities that help you troubleshoot without the need for TCP dumps and log analytics and things like that. So I would encourage you to go to avinetworks.com/webinars to take a look at a lot of the prior webinars on AVi Networks and its applicability for a variety of different load balancing use cases. One more question, Ashish, is about how AVi would work for Horizon Cloud.
Yeah, we have actually tested AVi for Horizon Cloud already, and it is a supported solution. So because AVi software, it runs natively in any public cloud, including Azure, AWS, and GCP. So we have tested, and it is supported in Horizon Cloud.
Great.
To add some, Chandra, to add some technical detail to that, from an AVi standpoint, the same way, right? There will be no difference in terms of how you would deploy AVi for Horizon in terms of configuring virtual service for Horizon Cloud. It will work the same way. All the analytics, all the automation, etc.
Fantastic, thank you. Team, if there's any other questions, feel free to put that into the Q&A panel now. If not, we'll close the webinar at this point and make a recording of this available. As I mentioned in the beginning, the slides from today's webinar will also be posted in SlideShare, and we'll send you a link to all of those registered and attended. Thank you again for joining today's webinar, and please feel free to reach out to us if you have any questions. Thanks, Ashish and Raghu.
Thank you.
Thank you.